Well, we've seen what normals are, we've seen how to display them, now let's go back to hiding them. Again, from the mesh menu, edit mode, overlays is a menu that we see when we are in edit mode. We deselect the faces and exit edit mode. Let's go back to hiding the collection boolean and move on to lighting our scene instead. I remind you to use as your rendering engine. Cycles. So let's go and set the viewpoint that we would like to frame with the camera. And to ask Blender to make the camera frame this view, we have the keyboard shortcut Ctrl plus Alt plus 0 on the keypad. In doing so, you see this rectangle was formed. Basically what has happened, the camera has now been moved so that it frames the view according to the position we were in. But no one prohibits us from selecting the camera and moving it like any other object. We can move it, we can rotate it until we get the framing we prefer. With the 0 key on the numeric keypad, we can switch from the independent view to the camera view. Then we can pass the rendered view to see what our lighting situation looks like. We see that something doesn't add up. What happened to our vaults? Here actually the vaults are there, they are still here. However, they are not visible to the rendering engine because I remind you that we used a copy of the cylinder that we used to do a Boolean operation. When we use the Bool tool add-on, the object that is hidden is also hidden from the rendering engine. Solving this is very simple. We just select the arc, we go inside the object section, we go inside visibility. In the ray visibility subsection, it's all unchecked. We simply click and drag the mouse until all the options. If we now return to rendered view, we return to our vault. We press the 0 key to go back to the camera view, and there we have our tunnel, obviously dark because I created the wall at the bottom. Our light source is outside the vault, and so as it should rightly be, our tunnel is dark. This light source, we can erase it, and so what is left is exclusively the ambient light. Let's go to the world section. We go to change the color of the ambient light, we put it white. So now we have exclusively as a light source this fictitious sphere around us, which projects from all directions a white light. The tunnel rightly being deep, as we go deeper into it, the light becomes less and less as rightly it should be because the light bounces and scatters. When we are in camera view, we have the option of asking Blender to render exclusively what is being framed. With Ctrl plus B, we can invoke a selection system. You see these two axes being formed. Let's go click and drag a selection box that goes to the whole camera rectangle. We let go of the mouse and see that now only what is in the camera square is displayed. This allows us to speed up the rendering preview. We can also do this for just a portion of the frame, or we can disable it with Ctrl plus Alt plus B. To have a more believable ambient light, we have the option of simulating the Earth sky. In the color section, instead of clicking on the white rectangle, where we can go to select the color of the light, we click on the yellow dot. We will then see what this means. This bullet we will see when we talk about nodes. For now, let's just see in this section how to use these options. Let's click on this little ball, which is a connector actually, and go to indicate that we want as color input not an RGB value, not a flat color that goes to cover the whole sphere, but we want a sky texture that is a texture that goes to simulate the sky. We select it and see that new options appear. At the bottom we don't have light because there is the planet Earth shadowing us, and at the top we have instead the light from the sky. We can indicate different parameters, for example the elevation of the sun. If we set a low angle, for example 2 degrees, the sun goes to the horizon. We also have the solar disk here, and so the light becomes more orange. On the other hand, if we set a higher angle, say 45 degrees, we have a cooler light and a different angle precisely because the sun is higher than the horizon. So we really have the ability to simulate a real sun illumination, and we are not using sunlight, but we are using world light, which is this sphere that surrounds us. But let us now return to visualizing what our camera frames and think about how to light the interior of our gallery. What we are going to do is to create windows, side openings, which will allow light to enter. We go back to the solid view, and by holding down the Shift key and right-clicking, we go to place the 3D cursor there. When we use this keyboard shortcut, that is Shift plus right-click, we are going to position the 3D cursor on the face of the object we are selecting. Let's try rotating the view. You see that 3D cursor rested right on the surface of our arc. Let's now go to insert a new object with Shift plus A. Let's look for a cylinder, which we can also leave of the default size. We will use this cylinder to create the openings in the vaults. Let's make sure that we still have it selected. Let's also select the vault, and with Ctrl plus, let's go do a subtraction. Let's go back to our room view, switch to rendered view, and see that we now have a window in the vault. Of course we can move the cylinder to our liking. However, I would like to point out that this hole is not repeated even in subsequent times, but only in the first one. Let's go and see why. This is a very important aspect that we need to understand just how modifiers work. If we go to the list of active modifiers, we see that the last one is the boolean that was entered when we pressed the combination Ctrl+. That is, we told Blender with this abbreviation to apply one subtraction of this cylinder at a time. This subtraction is precisely a modifier that was put at the bottom of the modifier list. You should know that the list can be even much longer. No one prohibits us from having dozens and dozens of modifiers. And Blender starts applying them from top to bottom. This means that first the array is applied, then the copying of the 4 vaults. Here, for example, we can increase and decrease the number of copies. Next, we have the application of the solidify, that is the thickening of the vault. After that we have the smooth by angle, and only after that comes, in this case, the boolean that goes to subtract the cylinder from the vault, to make this whole affect all the copies of the vault. This modifier has to be before even array. So what we can do is we can click on the side here where these dots are and drag upward. You see, the modifiers move to make room for the one we're moving. We're going to put it on top, and lo and behold, the hole now comes up again in all the copies. However, there is something wrong with it, because now it is no longer a hole, but is a kind of tooth, because when we go to apply the subtraction at this time, our cylinder does not yet have a thickness because the solidify only comes later. In order to drill the vault, there has to be a thickness, otherwise precisely we have this result. Then we have to make sure that solidify is even before subtraction. So we click and drag and put it right in the first place. Here we now have all the subtractions applied. So remember well, modifiers are non-destructive algorithms that are applied from top to bottom, and so their order of application is most important. When you come across unexpected results, especially when you apply multiple modifiers to an object, you need to check well with which order they are applied. Now if I move the subtraction cylinder upward, the hole obviously becomes smaller. Do some experimentation to go create the windows you like best. Of course, no one also prohibits you from scaling this cylinder to expand or decrease the light entry. Let's go back to the camera view. Now I perform a slightly more backward framing. To do this, I select the camera, I press the G key to move it, then I click the mouse wheel, and at this point I can go back and forth moving the camera along its direction. I confirm with the left button, then resume G again to move up, down, right, left. Back in rendered view with Ctrl+B, I can restrict the rendering to the camera frame only, as we have already seen. Then we can go and act on the parameters of our world to go and modify the behavior of the light inside the gallery. Let's click on the world icon inside the properties. We have the sky texture options. With the sun size, we can go and define the softness of the shadows. You see, right now, the sun rays define a very sharp edge between the shaded and the lighted area. If we go to increase this value of sun size, we will get a softer shadow. Let's try setting a value of 5, for example. Here we notice an already much softer edge that really creates a gradient between the lit and unlit areas directly from the sky. Do some experiments. For example, let's lower the sun elevation value to make the rays more oblique. Let's try, for example, to use 20 degrees. Using sun rotation instead, we are going to rotate the position of the sun. For example, let's try moving it 45 degrees. And we see how the result is completely different from the first configuration. In this case, for example, we see how the light rays go to illuminate the geometries of the gallery arches. Here's what I invite you to do, is to experiment with geometry and light. Do all the experiments you can think of. So perhaps add the number of elements in the arcs. Try creating more holes. Or scale rotate the cylinder we used to open the windows in the vault. Try varying the sky texture parameters here on the right. See what happens and try to understand how the light actually goes to change the result of our scene in a profound way. Finally, don't forget to save this work, because we may reuse it later to explore further aspects of using Blender. I will point out to you that during the rendering phase, especially in scenes where there is a lot of light bounce, darker areas versus lighter areas, however with more complex geometries, we have a lot of grain that, as the rendering engine processes, gradually goes away. Here we are in a preview phase, and you see here in the top left we have the maximum sample number 1024. And this little number that grows indicates how many samples have been calculated so far. We also have the possibility to apply, however, a denoise, that is a calculation that goes to artificially remove all these dots. If we go to the render section, this is indicated with the camera. We see that we have the possibility to decide in the viewport how many samples to do at most, in this case 1024, and whether to apply denoise or not. Let's try turning this option on and see what difference it makes. You see that immediately at the beginning we get a very pastel image, which by the way I like very much, because you can also use it to get some graphic effects if nothing else interesting. But you see, as the rendering engine calculates the samples and applies denoise, the image gradually gets more and more defined, cleaner and cleaner. This depends on you, what kind of visualization you want to have. Do some experimentation in this as well. Case. For this lesson we will stop here. However, I would like to remind you that if you would like to contribute to the publication of these lectures, you have the opportunity to purchase the handouts, whose link you will find in the video description. As they are updated, then they will still be made available to those who have already purchased them. In addition, I would also like to remind you that there is an index with all the topics covered, in which you can go and search for individual topics covered in this course, but also in previous editions, also in the other courses I have published on this channel, and then go and find the exact minute I talk about them. This could be useful just when you need to go over a particular topic or review a particular passage. As always, thank you for following me, and see you again soon.